Okay, good evening ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for tonight will be the actual derivation of the so-called quadratic formula in algebra. Let's try to bring out the so-called derivation. Let's start with the solution of this one. Okay. The form of a quadratic equation in algebra is something like it is given by this equation here, ex squared plus bx plus c is equal to 0. A here, B and C are all constants. Okay? And the unknown here is actually x. There should be an x1 and there should be an x2. And these are actually the so-called unknowns. Okay, guys? The form of the quadratic equation is actually given by the equation ex squared plus bx plus c equal to 0. Small letters a, b, and c are all constants. And x1 and x2. For x here, there is a subscript 1 and 2 here. Because since this is with the power 2, if we try to compute for the value of x, there will be 2 value of x. That's why I place it here. x1 and x2 are actually the unknowns. Okay, let's try to derive the formula for the so-called quadratic equation. We'll divide all the terms by a here. So it will become x squared plus b over ax plus c over a, and this should be equal to the given quadratic equation. We divide it all by a. So the first one will become x squared. The second one will be b over ax. The third one will be c over a. And for the right hand side, a 0 over a will still be a 0. Okay? So upon reaching this portion here, we'll take 1/2 of the ratio b over a. Then we'll try to square this one. We will take the coefficient of x. The coefficient of x is actually b over a. We'll take 1/2 of that one, then we'll try to square it. Okay? If we try to simplify this one, b to the second power will be b squared, right? And 2a quantity square will become 4b squared, 4a squared. Okay, you see it, guys? Because 1/2 of b over 2a will be actually b over 2a, and the square of b is b squared, and the square of 2a will be 4a squared. So what's next? We rewrite x squared plus b over ax plus, we'll add up this one here, b square over 4a square, and they should be equal to, we transpose c over a to the right hand side, so it will become minus c over a, okay, plus, for the left hand side we add this one, so for the equation to be balanced, we add b square over 4a square also on the right hand side, so it will become, this is b square, this is b square over 4a square, okay? You see it, guys? Okay, I'll try to check my camera. Okay, my camera is fine. So what will be next? I will continue here. So I will be making a vertical line here. I will continue the solution here. For the left hand side, this is now factorable to x plus b over 2a quantity square, and this should be equal to, okay? For the right hand side, this is now factorable to, or the simplification will be b square minus 4ac, okay, over this is 2a quantity square. That's the simplification of the right hand side. Because if we try to combine this one here, okay, I will get my reset. I'll show the simplification of this one. B square over 4a square minus c over a, right? We will add up this one here. We will add up. But this is actually, we'll multiply this one by 4a, and we'll multiply this one by 4a. Okay? Because 4a over 4a is actually 1, so it seems we're just only having c over a to combine this one here. So if we try to combine this one, it will become b square minus 4ac, okay? This is 4a square, this is 4a square, this will now be under one common denominator, 4a square. Okay, it is this. Okay, then what do we do? X plus b over 2a quantity square. Okay, this one here, if we try to expand this one, okay, I will place it here. It will be x square plus 2 times b over 2a multiplied by x plus the square of the last one, which is b square over 4a square. So these two here cancel with this. So it seems if we try to expand this one, this is the equivalent. Could you see it, guys? Yeah, you can see it. For the left hand side here, after adding b square over 4a square, I place it here that it will be same as the quantity x plus b over 2a quantity square. Because if we try to expand this one, what will come out is actually this one here. X squared plus b over a times x plus b squared over 4a squared. So instead of writing this expanded form, I will just write it as simply x plus b over 2a quantity squared. And they should now be equal to. Okay, I will try to erase this one so it will look good. Okay. This binomial here, if we try to expand, it is actually this expanded form here. But instead of writing this expanded form, okay, we'll just rewrite the binomial equation x plus b over 2a quantity squared. And for the right hand side, like what I said, it will become b squared minus 4ac over 2a quantity squared. And the proof of this is that if we try to combine this one here, I show you the proof. This is the proof. That is, I write first the positive 1b squared over 4a squared. This is minus c over a. So we could combine this one under one same denominator. We'll multiply the second one by 4a and by 4a, because 4a over 4a is actually 1. And again, if we try to simplify, b squared, c times 4a is minus 4ac. This is 4a squared. Okay, am I on camera? Yeah, I am on camera. Okay. This is 4a squared, this is 4a squared. So actually, if we try to simplify this one, this will be the resulting numerator, and the denominator will be the common denominator, which is 4a squared. So this is over 4a squared. And this should be equal to b squared minus 4ac over, this is 2a quantity squared. So to compute for x, we will raise all the terms, the left and right, to the 1/2. So for the left hand side, these two will disappear. It will just be simply equal to x plus b over 2a, and this should be equal to. For the right hand side, okay, if we try to take the square root of the right hand side, it could be the square root of the numerator over the square root of the denominator. And the square root of b squared minus 4ac will just be simply, I will write it here, plus or minus the square root of b squared minus 4ac, okay? And the square root of 2a raised to the second power raised to the 1/2, these two will disappear. So this will become 2a. Okay, you see it, guys? So x now will be equal to, we transpose this one to the right. So it will become negative b over 2a. This is plus or minus the square root of b squared minus 4ac all over 2a. And actually, we could combine the right hand side because the denominator here is 2a. The denominator here is 2a. So x now will be equal to negative b plus or minus the square root of b squared minus 4ac. Okay, the denominator are the same, so this is actually all over 2a. So this is actually the so-called this equation here will be the so-called quadratic formula. Okay, you see it, guys? X now will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's the so-called quadratic formula. And supposed to be, there will be two values of x. x1 will be equal to, x2 will be equal to. x1 will be by using the positive sign, and x2 will be, if we try to simplify the right hand side, it will be by using the negative sign. So in general, under the study of algebra, if we are given a quadratic equation, and we know the value of ABC, okay, to compute for the value of x1 and x2, we'll just use this formula here. We'll just substitute the value of ABC here, and actually we could compute for two values of x. And the first value is actually by using the positive sign on the quadratic formula. Okay? And the second value of x, which will be designated by x2, it is by simplifying the right hand side, but we must have to use the negative sign. So x2 is by using the negative sign. Okay, that's it guys. That's the so-called derivation of quadratic formula in algebra. Okay, this is Professor David J. De Los Reyes. Good evening from Los Angeles.